got Dr. Michio Kaku joining us right now, the theoretical physicist, author of The God Equation, much more. Genius is he, and kind enough to join us. Doctor, these images are stunning, and I know we're told we're only getting the smallest of the smallest percentage in, much more to come. What do you think thus far?
A Harvard scientist just broke the silence, and what he revealed will shake you to your core. 3I Atlas, a mysterious object from beyond our solar system, is shedding metals we've never seen before. Nickel without a trace of iron. It's moving at a mind-blowing 130,000 miles per hour, and its chemical makeup doesn't add up. Is it a freak of nature, or is something far more sinister at play? The question isn't just, what is it? It's, what does it mean for us? This object is moving so fast that it will never return to our solar system. Unlike comets that typically orbit the sun in elliptical patterns, 3I Atlas's velocity and trajectory suggest it is a visitor from deep space, passing through our solar system on a one-time journey. Its path is hyperbolic, with an eccentricity of 6.141, a value that makes it clear this object is not on a return trip to the sun. Instead, it is simply passing through, traveling too fast to be captured by the gravitational pull of the sun. Astronomers have confirmed that this object's orbit is unbound, meaning it will not be pulled back by the sun's gravity. This makes 3I Atlas the third confirmed interstellar object ever to be detected. Its speed and trajectory suggest it has come from far beyond our solar system, from regions even further away than the planets. The calculations show that 3I Atlas has already passed through the orbit of Jupiter, and after its slingshot around the sun, it will continue its journey into interstellar space, never to return. The scale of this discovery is immense, and it challenges our fundamental understanding of how objects from other star systems can interact with our own. What makes 3I Atlas particularly intriguing, however, is not just its trajectory or speed, but its chemical makeup. As the object began to approach our sun, its chemical composition was analyzed using a variety of telescopes, including the Very Large Telescope, VLT, in Chile. What was discovered raised more questions than answers. Spectral analysis revealed that the object was shedding metallic alloys unlike anything seen on Earth. Specifically, 3I Atlas was found to be emitting high levels of nickel without any detectable iron. This discovery defies the common understanding of comet and asteroid chemistry. Typically, when nickel is found in meteorites or comets, it is accompanied by significant amounts of iron. These two metals are often found together in celestial bodies, forged together in the intense heat of dying stars, and released together when these objects pass through the solar system. But 3I Atlas presents a different story. Its spectrum shows a strong nickel signal, 4.6 grams per second, streaming off the coma, yet there is no sign of iron. This is not just an anomaly. It is a fundamental contradiction to what scientists have come to expect. The presence of nickel without iron is unprecedented. It is like finding a gold ring without any trace of silver or copper, an occurrence so rare that it defies the typical patterns found in space chemistry. Harvard astrophysicist Avi Loeb has been among the first to raise concerns about this unusual chemical signature, noting that the lack of iron alongside nickel is unlike anything seen before in space. In solar system comets, the nickel-to-iron ratio generally hovers around 1:15, but in the case of 3I Atlas, the ratio is off the charts. There is no trace of iron, which raises an important question: how can an object from space have nickel without iron? Loeb suggests that this anomaly is more than just a strange observation. It could be a clue that 3I Atlas is not a natural object. While there are natural processes that could potentially separate metals in extreme environments, the idea of an object like 3I Atlas shedding such a specific combination of elements, nickel without iron, seems improbable without the involvement of some kind of engineering. For scientists like Loeb, this discovery is more than just a curiosity. It suggests the possibility that 3I Atlas may not be a random comet or asteroid, but could be something entirely different. It could be the first real evidence of an object that has been engineered, possibly by an advanced civilization. Loeb's concerns are grounded in scientific data. The very fact that the nickel-to-iron ratio is so extreme raises the possibility that these metals were deliberately separated, and that the object might not be a natural creation of the universe at all. This raises further questions about the nature of 3I de Atlas. If it is not a natural object, what is it? Could it be a probe or a message from an advanced civilization, designed to be intentionally placed in our solar system to study Earth and its planets? The idea of using metallic alloys as a means of communication, similar to the way humans have sent messages in bottles across oceans, is a fascinating thought. Just as NASA's Voyager probes were launched in 1977, with golden records carrying greetings from humanity, 3I Atlas could represent a message from another star system, crafted to survive the test of time and space. However, there are natural explanations that cannot be dismissed. Some researchers have suggested that the chemical makeup of 3I Atlas could be the result of extreme cosmic events, such as neutron star mergers or supernovae, which are capable of creating heavy elements in unusual ratios. These events could theoretically produce nickel-rich fragments that lack iron, and the absence of iron could be explained by the asymmetric nature of the explosion. In some instances, the distribution of elements in such events is not uniform, and certain elements like nickel could be ejected in clumps, while others, like iron, remain concentrated in the core. While these natural explanations provide a compelling narrative, they do not fully account for the extreme nickel-to-iron ratio observed in 3I Atlas. The possibility that the object was engineered, or at least influenced by intelligence beyond Earth, remains a valid hypothesis. In this sense, the discovery of 3I Atlas serves as both a scientific puzzle and a philosophical question. Are we witnessing the natural workings of the universe? Or are we looking at evidence of something deliberately designed and placed in our solar system? The object will undoubtedly provide more clues about its origins and its true nature. With each new finding, the mystery deepens, but so does the excitement surrounding this remarkable discovery. Whether it is a cosmic accident or the first evidence of extraterrestrial intelligence, 3I Atlas is forcing scientists to rethink the boundaries of what is possible in the universe. This interstellar visitor is not just another object passing through our solar system. It is a signpost, pointing us toward new frontiers in our quest for knowledge about the cosmos and our place in it. The discovery of 3I Atlas has given scientists a unique opportunity to investigate an object that seems to come from a place beyond our solar system, carrying with it an array of peculiarities that have forced astronomers to reconsider their understanding of cosmic objects. Following its detection, astronomers began the painstaking task of studying the object in detail using several advanced instruments, including the Very Large Telescope, VLT, in Chile, and more recently, the James Webb Space Telescope, JWST. These investigations have revealed some striking chemical signatures that continue to confound conventional theories about comet and asteroid formation. One of the most striking features of 3I Atlas is its chemical composition. As the object approached the inner solar system, astronomers observed the presence of nickel in its spectrum, in quantities that were both unexpected and unprecedented. The VLT provided the first clear indication of this unusual chemical signature, detecting a strong nickel signal emanating from the object. This was not particularly surprising. Nickel is commonly found in asteroids and comets. However, what caught the attention of astronomers was what was missing: iron. In all previous instances where nickel had been found in a comet or asteroid, it was typically accompanied by iron, forming an alloy that is common in celestial objects. Yet, in the case of 3I Atlas, iron was nowhere to be found. The absence of iron in a comet or asteroid is a puzzle. Normally, nickel and iron are found together in meteorites and comets because they are both formed in similar astrophysical environments. These elements are usually forged together in the cores of dying stars, and when these stars explode in supernovae, they release these metals into space. This process has been understood for years, and it forms the basis for how we understand the composition of most objects in our solar system. For example, In every comet that has been studied, the nickel-to-iron ratio has typically been around 1:15. This standard ratio has become a reference point for what scientists expect to find when analyzing the composition of a comet or asteroid. However, in 3I Atlas, the ratio is far off from the norm. In fact, there is no iron present at all, which raises serious questions about the formation and nature of this object. This anomaly became even more perplexing when additional observations revealed that the object was shedding the nickel in a way that was unlike anything seen before. According to data gathered from the VLT, 3I Atlas was emitting 4.6 grams of nickel per second, a significant amount. However, in contrast to previous observations of similar objects, there was no corresponding signal for iron. This raised alarm bells for many in the scientific community, as the absence of iron in the presence of nickel seemed impossible to explain by natural processes alone. This led astronomers, including Avi Loeb from Harvard University, to propose that the object might not be a natural formation, but could instead be something that was intentionally engineered. The idea of an engineered object is a provocative one, but the evidence supporting it is not easy to ignore. Loeb has argued that the lack of iron, combined with the unusual characteristics of the object, may suggest that 3I Atlas was designed or altered by an advanced civilization. But before jumping to conclusions about possible extraterrestrial intelligence, it is worth considering alternative explanations that might account for the object's strange behavior. One such explanation is that 3I Atlas might be a product of an extreme cosmic event. Some researchers have pointed out that there are astrophysical processes, such as the collision of neutron stars, that could potentially result in objects with unusual metal compositions. Neutron star mergers are known to create heavy elements in extreme ratios, and these elements could be expelled into space, where they might later be captured by a passing object like 3I Atlas. The process of a neutron star collision creates a chaotic environment where metals like nickel and iron are produced in unusual amounts, with some areas rich in nickel and others rich in iron. In such an event, it is conceivable that a fragment of the debris could have formed into the object that we are now observing, carrying with it an unusual chemical signature that is consistent with the findings seen in 3I Atlas. There is also the possibility that 3I Atlas's composition could be the result of cosmic radiation. As the object travels through space, it may have been subjected to high levels of cosmic radiation, which could alter its surface chemistry. This idea has gained some traction among scientists, as cosmic radiation can break down certain materials and cause chemical changes. The absence of iron could be explained by the fact that iron atoms are more susceptible to the effects of radiation, leading to their breakdown or displacement, while nickel remains relatively unaffected. This explanation, however, would not account for the complete absence of iron in the object, nor the extreme ratio of nickel to iron observed in its spectrum. In any case, the mystery of 3I Atlas's chemical composition is far from being solved. The object's behavior and composition continue to challenge our understanding of the processes that govern the formation of cosmic objects. As the object passed through the inner solar system, the team behind its observation used the James Webb Space Telescope to conduct additional studies. These observations revealed that the object's coma, or cloud of gas and dust, was dominated by carbon dioxide, with a carbon dioxide to water ratio of 8.1. This is a highly unusual ratio for a comet, as most comets typically contain around 4% carbon dioxide. The presence of such a large amount of carbon dioxide suggests that 3I Atlas is not like any comet that we have observed before. This finding is significant because it shows that 3I Atlas is composed of materials that do not align with the patterns seen in solar system comets. Carbon dioxide is an essential part of the composition of many comets, but the quantities observed in 3I Atlas are extreme. The production rate of carbon dioxide measured by the JWST was 129 kilograms per second, compared to just 6.6 kilograms of water vapor. This stark contrast highlights the fact that the composition of 3I Atlas does not fit the typical pattern of cometary chemistry. Some scientists have suggested that this could be due to the object being subjected to cosmic radiation over billions of years as it traveled through interstellar space, a process that may have altered its surface chemistry and resulted in the unusual carbon dioxide levels. Other researchers have proposed that the high levels of carbon dioxide could be the result of the object's formation in a different environment, perhaps a star system with vastly different conditions to our own. In addition to carbon dioxide, the spectral analysis also showed the presence of other compounds, such as carbon monoxide and carbonyl sulfide. While these are not as abundant as carbon dioxide, their presence further complicates the object's chemistry. The combination of carbon dioxide, carbon monoxide, and carbonyl sulfide does not align with the standard models of cometary chemistry. Some have suggested that these compounds may have formed as a result of the object's extreme journey through space, where it was exposed to intense radiation and other factors that would not be found in the inner solar system. Others, however, have raised the possibility that these compounds could be the result of a process that was engineered, pointing to the idea that 3I Atlas may be an artificial object. As the analysis of 3I Atlas continues, the data from both the VLT and the JWST are providing scientists with new insights into the composition and behavior of interstellar objects. While the natural explanations for the object's strange characteristics are still being explored, the idea that 3I Atlas could be something intentionally designed is gaining traction. Whether it is a natural formation or an engineered artifact, the discovery of 3I Atlas is forcing scientists to rethink what is possible in the universe. With each new piece of data, the mystery deepens, and the implications of this discovery continue to unfold. The investigation into 3I Atlas has drawn attention from scientists around the world, sparking debates not just about the object itself, but about the implications of its discovery. As researchers delve deeper into the data, more and more peculiarities are emerging, adding to the mystery surrounding this interstellar object. One of the most significant aspects of the investigation is the way in which the object's composition seems to defy the expectations built by centuries of astronomical observation. In the case of 3I Atlas, the chemical signatures observed by the telescopes have led many to consider the possibility that the object may not be a random celestial body, but rather something designed, or at the very least, influenced by intelligence beyond Earth. Looking at the object's characteristics, it becomes apparent that its composition is unlike any other interstellar object ever observed. One of the key points of interest is the metal content of 3I Atlas, specifically the high concentration of nickel and the complete absence of iron. Nickel and iron typically appear together in meteorites, comets, and other space debris, often forming alloys that are released when these objects travel through space. The metal elements in these objects are usually the result of the extreme heat and pressure generated in dying stars, where nickel and iron are forged together. When such objects pass through our solar system, they often shed these metals, which have been carried across space by the objects. The expectation has always been that when nickel is detected, iron will be present as well. Yet in the case of 3I Atlas, this has not been the case. The absence of iron in the presence of nickel raises immediate questions. How can an object composed of nickel not contain any iron? The answer is not immediately clear, and this has led some researchers, like Avi Loeb, to consider the possibility that the object is not a naturally occurring object at all, but rather a product of intelligent design. Loeb has pointed out that in all the meteorites and comets that have been studied, the ratio of nickel to iron is consistent. However, the ratio in 3I Atlas is nothing like this. It is in fact so extreme that it defies the natural patterns observed in our own solar system and beyond. For Loeb, this anomaly suggests that the object might have been engineered or altered in some way, potentially by an advanced civilization far beyond our own. While some may be hesitant to leap to such conclusions, the possibility of an engineered object is compelling, especially when combined with other data gathered from the object. The observation of a strange carbon dioxide signature further complicates matters. According to the data collected by the James Webb Space Telescope, the object's coma is composed of an unusual mixture of gases, with carbon dioxide dominating the volatile composition. This is not typical for comets, which usually exhibit a more balanced mixture of gases, including water vapor. The carbon dioxide to water ratio in 3I Atlas is 8:1, an extreme figure when compared to the typical carbon dioxide content in solar system comets, which is usually less than 4%. This finding further suggests that 3I Atlas is unlike anything we've encountered before. What makes this even more remarkable is the quantity of carbon dioxide produced by the object. The James Webb Space Telescope recorded the production of 129 kilograms of carbon dioxide per second. In comparison, only 6.6 kilograms of water vapor were produced in the same time frame. The sheer volume of carbon dioxide being emitted suggests that 3I Atlas is undergoing a chemical process that is unlike anything observed in solar system comets. The high levels of carbon dioxide have prompted some to question whether this is a natural process, or whether the chemistry observed in 3I Atlas is the result of an artificial process. The object's behavior is also a point of intrigue. Comets are known to produce a tail and a coma as they approach the sun, as the heat causes the ice and gas within the object to vaporize. However, 3I Atlas does not behave like a typical comet. As it passed through the solar system, it did not show the usual outgassing or tail formation that would be expected from a comet. Instead, it emitted nickel and carbon dioxide in amounts that seem to suggest an entirely different origin. While some researchers have suggested that the object could have been affected by cosmic radiation, which might alter its surface chemistry, this does not fully explain the extreme chemical composition observed in 3I Atlas. It is also worth noting that 3I Atlas is not the first interstellar object to raise such questions. In 2017, the interstellar object Oumuamua made headlines due to its strange behavior and unusual characteristics. It exhibited a speed and trajectory that suggested it came from outside our solar system, and its shape was unlike anything previously observed in a comet or asteroid. Moreover, it accelerated in a way that could not be easily explained by gravity alone, leading some to suggest that it might be a probe or a spacecraft. While the scientific community largely rejected the idea that Oumuamua was an artificial object, the questions it raised about the nature of interstellar objects remain relevant when studying 3I Atlas. The similarities between 3I Atlas and Oumuamua are striking. Both objects exhibit unusual velocities and trajectories, suggesting they are visitors from beyond our solar system. Both objects also display chemical compositions that do not align with typical cometary chemistry. Given the strange nature of 3I Atlas, it seems reasonable to ask whether we are dealing with something more than just a random object from space. If 3I Atlas is indeed engineered, it could provide humanity with the first tangible evidence of intelligent life beyond Earth. The idea that we could be observing a message from another civilization, encoded in the very elements of the object, is both thrilling and thought-provoking. One of the most intriguing aspects of 3I Atlas is its path through the solar system. As it made its way towards the Sun, the object passed close to Venus, Mars, and Jupiter. The alignment of these planets, combined with the extreme velocity of the object, has led some to suggest that this could not be a random occurrence. The chances of 3I Atlas passing so close to 3 of the inner planets are incredibly low, with some estimates putting the odds at less than 0.005%. These numbers have led some researchers to question whether the trajectory of 3I Atlas was intentional. If the object was deliberately directed towards our solar system, it would suggest that its purpose is more than just passing through. It could be a deliberate survey of our solar system, or even a message designed to be discovered at a particular point in time. The possibility that 3I Atlas could be a message or probe from an advanced civilization is a fascinating idea, but it is not without its challenges. Some researchers argue that the object's composition could simply be the result of natural astrophysical processes. For example, neutron star mergers and supernovae are known to create heavy elements in unusual ratios, and the unique metal composition of 3I Atlas could be the result of such an event. These natural processes could explain the object's strange chemistry without the need for intelligent design. However, the odds of such an object finding its way into our solar system are slim, and the highly improbable alignment of its trajectory only adds to the mystery. As the study of 3I Atlas continues, the debate between natural and artificial explanations will likely persist. The data gathered from the object has opened new avenues for exploration, but it has also raised more questions than answers. Whether 3I Atlas is a naturally occurring object or an engineered artifact, its discovery is undoubtedly one of the most exciting in recent years. The implications of this find are profound, forcing us to reconsider our place in the universe and the potential for intelligent life beyond Earth. The mystery of 3I Atlas is far from solved, but its existence is a reminder that the universe still has many secrets waiting to be uncovered. As the mystery of 3I Atlas continues to unfold, the implications of this object's unusual properties extend far beyond the immediate realm of astronomy. Scientists have been forced to reconsider their understanding of the cosmos, particularly when it comes to the origins of objects that travel between stars. The chemical anomalies and strange behavior of 3I Atlas have not only sparked intrigue, but have also raised fundamental questions about the nature of cosmic interactions and the possibility of extraterrestrial intelligence. If 3I Atlas is indeed a cosmic anomaly, its discovery could alter the way we approach the search for life beyond Earth and the understanding of interstellar travel. The journey of 3I Atlas through the solar system has been one of the most significant astronomical events in recent years, primarily because of the sheer improbability of its presence. The object was first detected as it passed through the solar system at an extraordinary speed of 130,000 km/h. Its hyperbolic trajectory indicated that it was not part of our solar system, nor would it ever return. This is something that has never been seen before, and its velocity places it in an entirely different category of celestial objects. The fact that 3I Atlas is moving so quickly and on such an unusual path suggests that it is a visitor from far beyond our solar system, traveling through space at a velocity that is too great for the sun's gravity to capture. What makes the discovery even more fascinating is the context in which it was found. Observations from astronomers in Chile, who were tracking the object with the Atlas survey, revealed that it was already inside Jupiter's orbit, but heading for a one-time slingshot around the Sun before continuing its journey into interstellar space. This information further confirmed that 3I Atlas was not a typical comet or asteroid. Its speed and orbit indicated that it had traveled from a distant part of the galaxy, and its path could help astronomers understand more about the movement of objects in interstellar space. However, it is the object's chemical composition that has truly left researchers scratching their heads. The discovery that 3I Atlas is emitting significant amounts of nickel without any detectable iron goes against everything scientists know about celestial objects. In all previous observations of comets, asteroids, and other space debris, nickel and iron are always found together. The two elements are usually forged in the cores of dying stars and are released together when these stars explode in supernovae. The presence of iron and nickel side by side has been a fundamental assumption in astrophysics. But in the case of 3I Atlas, this assumption does not hold. The absence of iron in a body that contains such high levels of nickel is something that cannot be easily explained by natural processes. The idea that 3I Atlas might be an engineered object, deliberately designed by an advanced civilization, is one that has captivated the imagination of many in the scientific community. Avi Loeb, a Harvard astrophysicist, has been particularly vocal in suggesting that the unusual nickel-to-iron ratio in 3I Atlas may indicate that the object is not a random natural formation, but rather a purposeful creation. Loeb's theory is based on the idea that the lack of iron alongside the abundant nickel could point to an advanced technology capable of separating these elements in a way that is not found in nature. While this theory is speculative, It is based on the fact that the chemistry of 3I Atlas does not align with the known patterns observed in other cosmic objects. The possibility of an engineered object being responsible for this strange chemical signature is further supported by the object's trajectory. The odds of 3I Atlas passing through the solar system in such a precise manner, skimming the orbits of Venus, Mars, and Jupiter, are incredibly low. Some estimates suggest that the likelihood of such a path occurring by chance is less than 0.005%. These odds have led Loeb and other researchers to consider the possibility that the object's trajectory was deliberately chosen. If 3I Atlas was not a random visitor from deep space, it may have been directed toward our solar system, either to observe it or perhaps even to deliver a message. The precision of its path, combined with the lack of iron and the presence of unexpected materials, raises the question, could this object be a probe or a message from another civilization, deliberately placed in our solar system for us to find? This idea is not entirely new. In 1977, NASA launched the Voyager spacecraft, each carrying a golden record with messages from humanity. The Voyager probes were designed to outlast human civilization, carrying with them music, greetings, and scientific information about Earth, with the hope that one day, some other intelligent species might encounter them. The golden records were a symbolic gesture, a message in a bottle sent across space, meant to convey a snapshot of human civilization to anyone who might find them. Now, with the discovery of 3I Atlas, some scientists have begun to wonder whether the object might serve a similar purpose. Instead of a golden record, the message could be encoded in the object's chemical composition, carried across space to reach us when the time is right. The similarities between 3I Atlas and the concept of the Voyager probes are striking. Just as Voyager was sent into space with the hope that it might one day be found, 3I Atlas could be seen as a time capsule, a piece of another world sent to us across the vast expanse of space. The idea that this object could be a form of communication is supported by the fact that the metal alloys and chemicals present in 3I Atlas are so unusual and complex that they do not fit the natural models we have for celestial bodies. If these anomalies are not the result of natural processes, it could mean that we are looking at a deliberate message sent across the galaxy by an intelligence far more advanced than our own. However, not all scientists agree with this view. Some argue that the chemical signatures observed in 3I Atlas can be explained by natural processes. Neutron star mergers, for example, are known to create heavy elements in unusual ratios, and the lack of iron in the object could be a result of such an event. These cosmic explosions are capable of creating metals like nickel in quantities that do not match the standard patterns observed in other stars or supernovae. Additionally, the presence of carbon dioxide, carbon monoxide, and other compounds in the object's coma could be explained by the object's exposure to cosmic radiation during its journey through space. These natural explanations provide a compelling narrative for the origins of 3I Atlas, and they should not be dismissed outright. Yet, the improbability of the object's trajectory, combined with the extreme chemical composition, continues to suggest that 3I Atlas might be more than just a random space rock. The possibility that it is an engineered object, placed in our solar system by an advanced civilization, is a tantalizing thought, even if it remains speculative. The idea that the object could be a message, an archive of sorts, designed to survive the harsh conditions of space and time, has the potential to reshape our understanding of how life might communicate across the cosmos. For now, the mystery of 3I Atlas remains unsolved, but its discovery has already forced scientists to rethink the way they approach the study of interstellar objects. As more data is collected and analyzed, the object may continue to provide clues that lead to a better understanding of its true nature. Whether 3I Atlas is a natural phenomenon, an artificial creation, or a message from another civilization, its presence in our solar system is a reminder that there is still so much we do not understand about the universe. The discovery of 3I Atlas is a call to continue exploring, questioning, and searching for answers, no matter how strange or improbable they may seem.